Hello, hello. All right, standard 5C. Going to give a brief little overview of this and then peek through the section 6.3, kind of covering the highlights. This is not a substitute for doing your own studying, your own review based off what we learned. Remember, you can access the book online if you don't have your physical copy. So standard 5C reads, I can use my knowledge of acids and bases to describe a simple voltaic cell, properties of acids and bases, and neutralization reactions. So you need to know a lot of really kind of basic memorization things about acids and bases. Some of the most, excuse me, some of the most kind of basic ones are acids are chemicals which donate or give away hydrogen ions, that's H+, which means they make hydronium with water, which is H3O+. Basically, you added an H+ to an H2O, which is water. Acids tend to be sour conductive. They tend to react with metal, and there's some other properties as well, which you'll find in the book. Bases are chemicals which gain hydrogen ions from solutions, which means they take in hydrogen ions, the opposite of bases. That means if they're reacting with water, they're going to take away an H+, leaving behind hydroxide, which is OH-. They tend to be bitter, they still conduct, they can still be dangerous and corrosive and things like that. When they react together, acids and bases, they neutralize each other. Since acids are giving away hydrogen ions and bases are taking them, it just cancels out and makes water. pH is a tool that scientists use to measure how strong or weak acids and bases are. Low pH means more acidic. Very high pH means more basic. 7 is in the middle, and it ranges from 1 to 14. Redox reactions, which is when we started talking about batteries, one half of the reaction is oxidized, which means it gives away electrons. The other half is reduced, which means it takes electrons. And so if you separate those two halves of the reaction, which is not the same as reactants and products, we'll see that when we get to the examples. If you separate those two, you can actually force the electrons being lost through the oxidation through a wire into the one accepting the electrons. And so since you're moving electrons through a wire, that's electricity. And so you can actually use a chemical reaction to produce electricity, which is exactly what happens in batteries. So now I'm going to flip over to the book section 6.3 and just kind of go over some of the major talking points. All right. So here we go. So it's titled Solutions to Environmental Problems because when they were talking about acids and bases, they talked about things like acid rain and acid runoff. So here in this picture, you can see trees that have been killed basically because of acid rain. The pH is too low, and that's coming from pollution. All right, so here are some examples where you have an acid like HCl, and it's giving away an H+ when it's reacting with water. That's what makes it an acid. Whereas NaOH, sodium hydroxide, is creating hydroxide, which is a base. So a lot of times if there's an H in front of the chemical, that's a good clue that it's an acid. And if there's an OH at the end, that's a good clue it's a base because it's going to be able to create hydroxide ions. One important point, which I've made but maybe not super explicitly, is that when acids are giving away hydrogen ions, you're not just going to have hydrogen ions floating around. Because if you're in water, water's going to grab those hydrogen ions. And so that's what this reaction is showing, is that HCl is giving away hydrogen ions, but those hydrogen ions are actually going onto the water, which is why we talk a lot about hydronium, because that's this H3O+ is a hydronium. Okay, so acids give away H+. If they give away all of their H+, they're called a strong acid. If they only give away some of their H+, then they're called a weak acids. Regardless, because they are creating ions, acids, and bases for that matter, but acids will always conduct electricity because charges are able to move around. All right. This is talking about bases. You have kind of basic bases, like sodium hydroxide, which is given OH-. And then you can also have some that are a little more complicated, like NH3, which it doesn't have an OH in it, but it can take an H+ from water making NH4+, and what's it leave behind? Oh look, OH-, so it still has that telltale indication that it's a base. So just like acids, bases can be strong or weak. Strong means they do a very good job of taking H+. Basically every single chemical takes an H+. Whereas weak, like NH3 for that matter, ammonia, they only take 1 in every 100 or even 1 in every 1,000 H+. Okay, so they're going to conduct electricity very well if they are strong bases and weakly if they are weak bases. And we use the pH scale to describe them. So I think this graphic is probably the most useful. If you're at pH 7, that means just water. Water naturally has some hydronium in it, specifically 10 to the negative 7th power. And then when you do this negative log of 10 to the negative 7th power, you get a pH of 7. If you start increasing the H3O+, because there's this negative here, it's actually going to decrease the pH. So that trips people up sometimes because they're like, I know pH measures acidity, and they think that high pH means more acidic. It's actually the opposite because of that negative. And so something like battery acid with the pH of 1 or 0 is going to be very, very acidic, whereas something like coffee with the pH of 5 or even 6 is not as acidic. It's very weakly acidic. So there's actually a lot of things that we eat which are considered weak acids or weak bases. But if you get too strong of an acid or a base, it can be toxic because the materials are corrosive. They eat away at things. You can also talk about POH, which is the same equation but of hydroxide. And so it's essentially just flipping it. So if something has a pH of 1, then it would be on the opposite side for POH, so it'd have a pH of 13. Usually people just stick to pH because it's less confusing, but it's good to know that if you do see POH, it's just flip it, all right? Instead of 12, it would be 2 because it's flipping over 7. Acid runoff happens when there are mines that people don't take care of properly, and water goes through the mines, picking up acid on the way out, and it can damage a lot of materials. These colors are actually, when it's becoming less acidic, believe it or not, when it's mixing with kind of normal neutral water. And what's happening is all the metals that it's dissolved, because acids dissolve metal, can no longer stay dissolved, and so they're falling out. And so here they have a lot of iron, and it's creating this kind of iron sulfate yellowish orange color. So different animals have different resistances to pH. Some things which have shells tend to dissolve in acid. So snails and clams, if the pH drops even a little bit, they tend to die. Whereas other things like frogs are more resistant. pH 4 is actually pretty acidic for water, and they could still be alive. There have been some cases of acid runoff so bad that they've just killed miles and miles of river. Mostly with the Environmental Protection Agency, a lot of those have gotten better. Remember, you can test it using pH paper. You did a lab with that. We talked about neutralization reactions, the idea that acids and bases can cancel each other out. So for example, if you take the hydronium from the acid and the hydroxide from the base, that H+ is just going to go to the OH-. That gives you 2 H2Os left over. So it just neutralizes and creates water. And then the other ions left behind create something called a salt. So in this example, they're taking HCl and NaOH. So the Cl- and the Na+ create NaCl, which is table salt. But it doesn't have to be table salt. It's just whatever's left behind. So like if you took sulfuric acid, which is H2SO4, then the SO4 would be part of the salt, and that's definitely not table salt. So they neutralize each other. If they're both strong, they neutralize completely. If one's stronger than the other, then the pH tends to favor the stronger one. So if you mix a strong acid with a weak base, your resulting mixture will probably still be slightly acidic. Some solutions to acid precipitation. There's a lot of engineering solutions that people have done to basically, before the combustion gases leave the factory or the power plant or whatnot, they essentially treat them to remove the chemicals that create the acids. So one of the biggest chemicals that creates the acids is sulfur. So sulfur makes sulfur trioxide, which can then mix with water to create sulfuric acid, which is a strong acid. And so what they do is they basically take the gas and then spray it with this water that has some calcium carbonate in it. And the carbonate mixes and reacts, taking away the sulfur. Now, in the process, it creates carbon dioxide. And so it's contributing actually more to greenhouse gases, but it's contributing less to acid rain. And of the two issues, acid rain is the more immediate threat. So it makes sense to do this. But the best way to stop pollution would be to stop burning things. Easier said than done, though. One idea to stop burning things is to replace vehicles with electric cars. However, it is important to keep in mind that where's your electricity coming from? Because if your electricity is still coming from combustion, you're still polluting the environment. Maybe a little more efficiently, maybe not as bad, not as dangerous, but you're still polluting the environment unless it's coming from something completely created using no combustion, which so far there is nothing that is completely created using no combustion. There's things that are less, like wind, for example, wind power. If you use a windmill to charge your electric vehicle, it creates much less pollution, but it still creates carbon dioxide when you make the wind turbine. So just always keep in mind that idea that you want to look at the entire life cycle if you're thinking about vehicles. Acid precipitation tends to occur more dramatically in developing countries. Europe and America had this problem a few decades ago and then have really cut down on it. China also has been making great strides. If you look in 10 years from 2005 to 2016, they have much less pollution. But then notice India, which is kind of developing a little bit behind China, now has more pollution. And so it's tough because you can't just say, hey, no, you can't pollute, because that means they can't get energy. And no energy means no electricity, means a much worse quality of life. So it's a difficult situation. Okay, now one of the major problems if you do try to switch to renewables like wind and solar is you can't control when you get the energy. So you need a way to store the energy so that you can use it during the nighttime or when it's not windy. And so this is where the redox reactions, reduction oxidation, and the batteries come in. So you can actually make an electric current if you use an oxidation and reduction reaction. So here you have zinc plus copper 2 plus going to copper plus zinc 2 plus. So what this means is that the zinc is losing 2 electrons because it's turning into 2 plus, it's losing 2 negatives. So that would be oxidation. So the oxidation half reaction would be zinc goes to zinc 2 plus 2 electrons, whereas the reduction half reaction would be copper 2 plus the 2 electrons, it's gaining the electrons, just goes to copper. It's helpful to remember oil rig. Oil stands for oxidation is loss, and rig stands for reduction is gain. So you can keep the two straight. So what they've done in this setup here is they've separated the two reactions. You've got the zinc on the right and the copper on the left, I believe. And so what happens here is the zinc loses those 2 electrons. They go through the black wire and then come out the red wire. And in the process, they're creating a voltage because the electrons are pushing on this voltmeter. And you can use that to power a motor or light up a light bulb or what have you. Now notice there's this paper towel in between them. This paper towel is called a salt bridge. What they've done is they've taken a dissolved salt, like sodium chloride. Doesn't have to be, could be another salt. And when you dissolve it, it creates ions. So that allows the charges to balance out. because otherwise what would happen is the blue one, which is getting reduced, would just constantly be gaining electrons and would be gaining a negative charge. And at some point, it would be so negative that you couldn't add any more negatives because negatives repel. And so what the salt bridge does is it allows that salt to balance out the charge, but the electrons are still able to keep moving. So the battery doesn't stop until you run out of your zinc and your copper. Otherwise, it would stop early. Some vocabulary you're going to need to know. So the one producing the electrons is the anode. It's the negative part of the battery. And the one gaining the electrons is the cathode. That's the positive part of the battery. So anode means oxidation's occurring because it's where the electrons are coming from. And then reduction would be occurring at the cathode. There's different types of batteries. You should just kind of a brief idea of the different types. Alkaline batteries, lead storage batteries, and lithium batteries. Lithium's what they tend to use in smartphones and electronics. Lead tend to be cheaper, but they're heavier and bigger, so they use them in cars. They're still rechargeable though, so that's nice for cars. Alkaline, they call disposable ones. It's not really a great idea to throw them in the trash. You're supposed to give them to these hazardous material collection events because they do have those bases in them. Alkaline means basic, and that can be corrosive and dangerous, which is another reason if you ever have batteries that get that like white powder on them, if you have gloves, use them. If you don't, it's not that big a deal, but make sure to wash your hands afterwards because that is kind of corrosive. Okay, so I believe that's it for this section. Yes, it is. If you have questions, I have office hours. Happy to help out.